let's solve a problem where we want to remove even numbers from the list. And I have an example here. I have a list of numbers 1, 2, 4 and 6. And I would like to get a result where I only have element 1. So basically all the even numbers are removed. I only get this one odd number here. And let's see how not to do that. So one way would be to iterate over the list 4, and I use enumerate. I use enumerate to get the index or the position and the element itself. En number in enumerate, and I don't have the list. Let's say numbers. It's 1, 2, 4, and 6. Enumerate numbers. Let's print out what I get. So I get position and element value. So basically I can draw here 0, 1, 2 and 3. Those are the positions or the indices. And now I want to remove the element if it is an even number. To do that, I use conditional statement here. If number is even, so if the remainder when we divide it by 2 is 0. So basically if I divide it into 2, nothing remains. That's an even number. If 1 remains, then it's an odd number. Okay, so if the modulo of 2 is 0, then let's try to remove it. And I try to remove it so that I know that numbers or the list has a method called pop. And inside this pop I have to pass the index. So I want to pop out element at this position. And because I know this position, this is I, this is the index or I in my code here, because of this enumerate, which gives me for every element both index and the value of this element, so I can pop it out. And yeah, if it's in the case if it's not, there is nothing to do, so I don't even want to add this else here. And let's print out numbers. What's left after executing this code? So now I execute this code and I see that the result is 1 and 4. How come that if I run this code, I go over every element, if this element is an even number, I remove it. But in the end, why the 4 remains in this list? And here I actually even have this printout from this line here. We can get some idea what's happening here, but let's go over it on the board. So basically what the for loop does is that it takes next, or basically we can say that there's this I, which is 0, 1, 2 and so on. So basically it takes an element at this position. It doesn't matter whether we change the list during the cycle or not. It just, the I value or the index value just increases by 1. Until the end of the list is reached, then the loop breaks, or the iteration is not even started. And what happens here? First, we have this list, I is 0, and we have this check whether this number is odd or even. Because it is not odd, nothing happens. There is no pop. We go on. Let's draw here. So we are here now. The I value is 1. This I here, it doesn't have to be I. It's just an example that during the loop, it doesn't matter what's the name of your variable. In my code here, I have I, but it can be whatever this points here to the index. So whatever, even if I have the loop without the enumerate, it still works so that it takes indices or it takes one index from your list, then the index increases. It doesn't, this is the way how the loop knows where it is actually. It just stores this position. Okay, now we have this I is 1, so we are looking at the second element here. Because this is an even number, what happens is that numbers.pop pops out element at this position. So after pop we will have 1, the 2 is popped out, and because of the popping out everything else is shifted left. We will have 4 and 6. So this is our list currently, and I was here 1. Now with the next loop I becomes 2. If you see this list, you would probably think that the next element, or here you think that the next element might be this 6 here or 6 here, or actually, yeah, not 6 here, but this 4. Sorry, I already was thinking for the solution. It should be this 4. Also here you think that now 2 was removed, now we move on to this 4 here. But because we operate with this position, I becomes 2, and now I check this position here, because this is 0, this is 1, and this is 2. And now we are checking whether this element here is even, and it is. We also pop it out. We pop out element at position 2, we end up with 1 and 4. So what happened is that because we removed this 2 here, everything was shifted, but because this index works separately, it doesn't care whether you remove something or even if you add something. For example, if I add something here, I would end up at the same position always. So it doesn't move to the next element. For example, if I add 2 here, every time, although this index increases by 1, you get this added element. So you don't reach automatically to the next element in original list. So yeah, you have to keep in mind that during loop, it's not wise to remove or add anything. So basically during the loop, it's not wise to modify the list. In some programming languages, it's not even allowed, but the Python allows it. In certain cases, it might even be required to do, but usually it's not. And instead, for example, in this example or in this problem, we can, there are different ways to solve this. For example, one way would be that, okay, let's loop over for I. There is actually no need for the I, for number in numbers, and we will have the new list as a result. And if the number divided by 2 gives us 1 as a remainder, then we add it to the new list. So currently, instead of removing even elements, I add odd elements to a new list. So I can say that result append number. And here we print out the result. We see that I have only this 1 here. Okay, but some cases you have the requirement that you have to modify the existing list for whatever reasons. Then it doesn't work if you create a new list. And in those cases, it might be, for example, wise to store everything you want to remove into a separate list, and after looping over, you remove those elements you stored in your helper list. For example, in this example, I will go over this list and store every position where I want to remove something, or every value. Again, it depends how you want to approach this, but I store that I want to remove 1, 2, and 3. So basically the positions where I want to remove something. And now I can, in a separate loop where I loop over this list, I can remove elements from here. But of course you have to understand if I do it so that I go over this list in the same order as I've written here, the same problem appears. So basically I remove element at position 1, everything is shifted. Now I remove element at position 2, but position 2 is this one here. So 6 is removed and 4 still remains. So if you want to use pop, you probably have to go over it backwards, or another way would be to store the values you want to remove. And now you can remove every 2, every 4, every 6. Of course, this approach doesn't work if you want to remove some of the 4s, but not all the 4s. Then you have to still have the index version of removing elements. But then, yeah, you have to keep in mind that if you start from the larger value, nothing happens if you shift, because only the elements to the right of this position are changed, and because you are moving in that direction, everything remains the same left to this position. So let's see what we can do here. So let's say we have this IN number in enumerate numbers. And let's say to remove list. We have a list which I have to remove. And now if this number is divisible by 2, then I add this to this index into this to remove list. And now I will just go over this list backwards. I can do it as for I in to remove, but I can use slicing here, and this is one neat way to reverse the list. I can just use the start and end positions as default, beginning and end, and step is -1. So basically it just goes over the list, or basically it reverses the list because the step is -1, so we have 3, 2, 1. And now I can remove. And you can see that although I use popping inside a loop, but it's a different loop. So here I loop over this list, but remove from this list. So earlier I used the same list for looping and removing, then I had the problem. But here I can loop over this list and then remove elements from another list. And now if I print out numbers, I will have the only element 1 here. So the main point here is that don't modify the list if you are looping over the same list. You will get unexpected results. You even don't have to get an error, as I didn't have an error. I just add a wrong result, not expected result. So if you have a loop, don't change the loop, change the data structure you are looping over. So try to do it in a separate loop or separate step, as I showed you some possibilities.